Okay, our first example states that we have a door, and I'm going to begin by drawing a picture. Now, the problem says that 75 centimeters or 0.75 centimeters from our hinge. This is going to be my hinge. So this would be a top view of the door that's going to swing open. The distance the force is from the pivot is 0.75 meters. Now, the problem states that we apply a force at that location of 240 newtons. So here's my force vector. And we apply that force. Remember, the size is important. So here's the size, magnitude. Now we have to look at the direction. It says 20 degrees from being vertical. So does 20 degrees go here or here? Because this is my vertical, the 20 degrees should go here. And the problem asks, what is the torque? So there's our picture. Now the next step is going to be to find my components of this force. Really just my perpendicular components, all I'm interested in. There are two components here. We have a vertical component. That's our perpendicular component. And we have a horizontal component. Now, if I were to pull straight out or push straight in on this door, it's not going to cause any rotation. So I'm only concerned with finding my perpendicular force. So let's look at what I need to do. Here I have a right triangle and an angle in my hypotenuse. I'm looking for the adjacent side, so that means I need to use cosine. So F perpendicular equals 240 times the cosine of 20 degrees. Now, you could also say that if this is 20 degrees, this angle is 70 degrees, and you could use sine of 70. Either one of those are appropriate. Okay, so here I have my component, and I have the distance from the pivot. Remember, that distance from the pivot we know as R. So the problem now asks us to find torque. Torque equals F perpendicular times the radius. So let's take these values and multiply them together. I'm going to substitute 240 times the cosine of 20 degrees in for force perpendicular, and I'm going to multiply that by 0.75 meters. So my net torque, when I type this into my calculator, I get approximately 170 units of torque. Now let's remember our units for torque are Newton meters. And again, that's because we're taking a force and multiplying it by a distance. Okay, there's example 1.